In the last video, I discussed about how we derive the equation of motion in a spring mass system. That means when a spring of length lowercase l is there, and if you attach an object of mass m at the bottom end of the spring, then that mass, that object will oscillate for some time and stay in the equilibrium, right? So in that case, what will be the equation of the motion of that object? So we derived that. We got m times y double prime minus gamma times y prime plus ky equals to ft, where m is the weight of that object, right? And y is basically the distance that the object moves from its equilibrium position. So y is the same y. Okay, so gamma is the damping constant, okay, damping coefficient, and k is the spring constant, and ft is the external force, right? So where the weight m is found by the m is the mass of that object, okay, m is the mass of that object. We given by, if the weight is given, then W is equals to m times the g. G is the gravitational force, right? So if you are asked to find out m, then we write W over g. Usually weight of the object will be given to you, okay? Weight will be given to you, and then you will have to find out mass of that object from the weight formula. Weight is considered as a force here, so W is equals to m times g, where m is the mass and g is the gravitational force, right? So so if you solve for m, what do you get? M is equals to W over g. So if the weight of the object is given in terms of the kilogram, then the mass will be equals to the weight, okay? If the weight of the object is given in terms of the kilogram, then mass will be just weight. But if the weight of the object is given in terms of the pound, then you will have to do mass equals to W over g, where g will be 32 pounds, okay? That's how we find out, okay? And gamma, to find out the gamma, which is the damping constant, we use gamma equals to resistance force divided by the velocity, okay? And then to find out the k, we use again W is equals to k times L, that is mg equals to k times L. And if you solve this, you'll get k equals to mg over L, that is the weight of that object over the displacement of the object after you hang that object, okay? Displacement of the spring after you hang the object, or the extension of the spring, okay? So let us see some examples, and then we will use all these formula there, okay? So let us do the first example. It is an example from the book. So what it says is a mass weighing 8 pounds stretches a spring 6 inches. So what is given there? The weight is given, right? So weight is given as 8 pounds. Weight is given as 8 pounds, right? And then it stretches the string 6 inches. What is given? L is 6 inches given, right? So here the L is the 6 inch. That was the extension of the spring after you attach the of the object, right? So 6 inch can be written as 1/2 feet, okay? So 6 inch and the 1/2 feet are the same thing, so it can be written that way, okay, guys? So what is the formula to find out k? It is asking the spring constant k, right? So what is the formula? K is equals to W over L, right? So what is W? W is 8 over L is 1/2, right? That will be 16 lb, right? So it will be what? It will be 16 lb per feet. So this is the answer. That is the spring constant of this spring, okay? All right, let us see another example. A mass of a weight 2 pounds stretches a spring 6 inches. So there is a mass, there is an object of weight 2 pounds, okay? That is, if you hang that object on the spring, then that spring will be stretched by 6 inches, okay? So what is given here is weight is equals to 2 pounds, right? So, and then L is given as 6 inch, right? So 6 inch. So how much is that? That will be 1/2 pound, right? Okay, that's what we got. Now let us find out the spring constant from here. So what is the spring constant? Because we will be using, so here you are finding the equation of the motion, so we will need m, gamma, k, all those things, right? So what is k? K is W over L, that is 4. That's what I found, k. Now how about the m? So this is, weight is given in terms of the pound, right? So what I'm going to do is m is equals to, I'm going to use W over Z. W over Z. What is W? W is given as 2. Z is 32. So that is 1 over 16, right? That's what you got. 1 over, mass is 1 over 16 pound, pound second squared per feet. That is the mass. Okay, so what is the value of gamma? So we know we have m, we have k. What is the gamma? Gamma is equals to 0 because it says that there is no damping, right? Since there is no damping, gamma is equals to 0, and there is no external force, so F is equals to 0 as well. So what is the equation of the motion here? So the equation of the motion will look like m times y double prime plus ky is equals to 0, right? What is m? M is 1 over 16, y double prime plus k is 4, and then y is equals to 0. This is the equation of the motion. Okay, now let us do another example. So it says a mass of 4 pound stretches a spring 2 inch. Okay, so from this we can find out actually the mass m. Okay, so let us see, this is a weight. Okay, mass of weight, let's see weight. Mass of weight 4 pound, an object of weight 4 pound stretches a spring 2 inch. Okay, so let us write on the given things. What we have given, weight is 4 pound, right? And then what is L? L is given as 2 inch. So 2 inch means what? 2 over 12 feet, right? So that will give you what? That will be 1 over 6. 1 over 6 feet, right? So how do I find out k then? K will be what? The formula is W over L, right? So what do you get? You got W over L is 4 over 1 over 6, right? That will be 24 pound per feet. That's what you got. How about the mass? Mass of that object will be weight over the gravity, right? So that will be 4 over G is 32. That will be 1 over 8, right? Pound times second square divided by, or per feet, you can say that way. So pound second square per feet. Let me write down per feet, not in the divide notation, just slash. That will be clear, I think. So that will be feet. Pound second square per feet. Okay, so from the given first sentence you can find out value of k and m. Suppose the mass is pulled down additional 6 inch and released. So you pull down the mass additional 6 inch, okay, and then you release it. All right, so what we want to do here is we want to find out, also let me read the when so the mass is in the medium that exerts a viscous resistance of 6 pound when the mass has velocity 3 feet. So what is it saying is, it is saying it is giving some information to find out the gamma, right? So what is the gamma? Gamma is the resistance force over the velocity. See here, to find out the gamma you can do 6 resistance force, right? Because this is the viscosity of the, so the medium is the viscous fluid, right, which has a resistance 6 pounds. So we will do 6 over the 3 feet per second, right, because the velocity. So let me write on that. Gamma is equals to resistance force over the velocity, right? So 6 over 3. So 6 pound over the 3 feet per second. 3 feet per second, right? So if you do that, you will get 2 pound second per feet. That's what you get. Can we write about the equation then? Say hence the equation of motion is, what do you get? So m times y double prime minus gamma times y prime plus k times y equals to f of t. There is no external force, that f of t will be 0, right? So what is m? M is 1/8 y double prime minus, what is gamma? Gamma is 2y prime plus, what is k? K is 24y is equals to 0, right? If you multiply all the terms by 8, what do you get? You get y double prime minus 16y prime, okay, plus 192. Y is equals to 0. Now, see, we didn't use one of the thing here. Suppose the mass is pulled down additional 6 inch and released, okay? So what is y at 0? At the beginning, what is that object? It was pulled down 6 feet down. Since the downward direction is positive, you can write y0 equals to 6 inch, not feet. 6 inch, that is 1/2 feet, okay? And what was the initial velocity? Y prime of 0 is the initial velocity of that object because it was released from the rest, right? Because it was pulled down and then released it. So this is the initial condition. So basically this sentence is giving you the initial condition. So this is the initial value problem you get from this question. Okay, guys. So this is how we answer the some basic questions related to the spring mass system. But in the section 4.4, you will see more details on the more detailed and advanced example and theory of the spring mass system. Okay, guys. Thank you.